go to page 102, we are going to look at polygons. What are polygons? What are polygons? Polygons are shapes. Shapes. It's a flat shape. It is not 3D. So one of the things you need to know is that it's a 2D shape. That's what a polygon is. 2D shape. It has to have at least 3 sides. Why? Why? Because if you only have 2 sides, that is not a polygon. A polygon must be closed. So we have to have at least 3 sides. We can definitely have 4 sides. That's a polygon. We can definitely have 5 sides. That's a polygon. Now, can I have a circle in a polygon? Some type of curve in a polygon? No. So they have to be straight lines. So a polygon has to have straight lines. You have to have at least 3 sides, and it must be flat shaped, 2D. Now, for this particular section, we are learning about polygons, but we're going to be more specific. I'm going to say the word regular polygons. I am going to say the word regular polygons. And I'm going to go to a new page, and I'm going to write regular polygons. And what's the difference between a regular polygon and just a polygon? What's so important that I use the word regular? Yes. Oh, that's beautiful. Beautiful, beautiful. Oh. So what you have to know is that all sides are, you could say the word equal. You could say that they are all the same. You could say that they are congruent. Congruent. This all means the same thing. And the other thing that's very important to know for a regular polygon, if I show you an equilateral triangle that all sides are equal, or if I show you a quadrilateral where the square is the only one that's a regular polygon, or I show you the pentagon with all 5 shapes, that is regular. Or if I do the hexagon, 1, 2, 3, 4, 5, 6, and tell you each side is equal. There's one more thing that you have to recognize that they all have. So their sides are all equal, and guess what else is all equal? Angles. The sides are all equal, which means that the angles are all equal. That's what makes it a regular polygon. Sides are equal, angles are equal. Sides are equal, angles are equal. For now, I'm not going to get into the angles of my polygons. I am going straight to area of regular polygons. All my angles are equal. So polygons, which is a new kind of word for us to use, even though we've been dealing with polygons for a very, very long time, like the rectangle, the trap, all of those are polygons. We are now going to talk about regular polygons. The pentagon, the octagon, the decagon. Those words that you heard somewhere in elementary school once upon a time. We're now going to deal with them and find the area. Okay? So I'm moving forward. I'm moving to a new page. And I'm going to use the pentagon as an example to find the area. 1, 2, 3, 4, 5 equal sides. So far, so good? I need to find the area inside of this polygon, this regular polygon. Check out what I'm going to do. There's a shape. There's a shape that lives inside my pentagon. Who thinks they know what shape lives inside my polygon? The triangle. How many of these triangles live inside the pentagon? Oh. How do I change this? No? What? Here, like this?
You have to press the little notification thing at the bottom.
This?
Yeah.
This? Thank you. And how do I get rid of that?
Yeah, erase it.
Erase it?
I think.
Yeah, thank you. So, getting back to math, glad you guys know more than I do about the smartboard. My question was, how many of these triangles live inside the regular pentagon? 5. 1, 2, 3, 4, 5. Do you see how there's 5 triangles that live in there? What else is 5 in the pentagon? 5 sides. So the relationship between the sides and the triangle, that they're the same. The sides. So if I have an octagon, which has 8 sides, how many triangles will I have in there? 8. If I have a decagon that has 10 sides, how many triangles? 10. So there's a relationship between the sides and the triangles inside. Do you agree so far? Inside, what kind of triangles do I have? Can anybody recognize the type of triangle that I have? Yes? No? A nice isosceles triangle, where these two sides, guys, check it out, these two are the same, but not the base. And they're all going to be isosceles triangles except for one, and that's the hexagon. But I'm going to deal with that later. For now, what I want you to know is if I had to tell you the area, if I had to ask you to find the area of this, and I gave you the height of one triangle. Let's say I gave you the height. And I told you, hey guys, the height is 3 and the base is 5. Would you be able to find the area of my whole regular polygon called the pentagon? Yes, good. Can somebody tell me what they would do? Michael.
Well, I would do formula for triangle.
Good, triangle, because we know one triangle. Everybody checks up. Check, 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 check. Everybody's looking. There's one triangle in there. We all know, da, 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 we all know the triangle is base times height divided by 2. Do you agree with me? And then, what would you do once you found the area of one triangle? You would times it by 5 in this case, but if you didn't know how many sides there was, you would times it by the number of sides, which we're going to use the letter N for it. N stands for number of sides. In this case, yes. In this case, yes, it's 5. So let's fill in what we know. So the area of a polygon the area of a polygon, area equals base times height divided by 2, timesing it by 5. Now, do I have to put a times in the middle, or do you guys get that this is a multiplication here? You get that that's a multiplication?
Yeah.
So basically, I'm doing 5 times 3 times 5 divided by 2. And reality is that if you can do this, you know how to find the area of a regular polygon. What I'm going to do now, though, hopefully not confuse you, is give you the right letters for it. I'm just going to move forward. I'm going to redraw that to explain something that we don't call this a height. We don't call it the height. There's a very fancy specific word used for the height inside the polygon. So give me a second. I'm going to redraw 1, 2, 3, 4, 5. I'm going to have my center point. I'm going to redraw the triangle. And now I want you guys to notice that I'm going to call what we called the height before is not the height, is the apothem. So some people say apothem, some people say apothem, potato, potato, I don't care what you call it. I'm going to call it the apothem. A, little baby a, is equal to the apothem because the big A represents what? Area. So apothem. Now, rather than calling this the base, they call it the side length. So the base is actually, S is equal to the side length, which is known to us as the base. Okay? And the last thing that I did mention was what? N stood for number of sides, which is the number of triangle. And if I use this, the ASN, I come out with the formula for a polygon. Check it out. I'm putting the formula. You have to square it, highlight it, put a big circle around it in your test. The formula is area equals A for apothem times side length for the base. N for the number of sides or triangles. Same thing, right? What am I missing? Michael, what am I missing? Division of 2. And this, ladies and gentlemen, is the formula that you will use all the time. Does ASN have to be in that order? No. I have teachers that call it NBA. You know what NBA stands for? Besides the basketball NBA, what NBA stands for? Number of sides. Base, apothem. It's going to give me the same answer. Our book right now uses ASN divided by 2. So I am going to be consistent with the book and hopefully the tests that you see. We are going to do examples in the next few minutes.